In section 7.4, I'm going to explain how you can solve quadratic equations by completing the square. Now, a quadratic equation is any equation that's in the form ax squared plus bx plus c equals 0. So this right here is a general form of a quadratic equation. And we've already learned that we can solve these equations if we can factor this left side. So if this left side of the equation factors, then you can set each factor equal to 0 and solve them separately. And that's called the factoring method. But it's not always possible to factor that left side, so we'll need to have a strategy to use when that doesn't factor, and that's called completing the square. Now, the method of completing the square uses something called a perfect square trinomial. So I want to take a few minutes just to explain what that is. So if you take some binomial, let's say x plus a number or x minus a number, I'm just going to use x minus 4, and you take that in parentheses and square it, let's see what we get. We do FOIL on that, so we'd have to do x minus 4 times another x minus 4. And when we did the first, the outers, and the inners, and the lasts, we'd end up with x squared minus 4x, and then another minus 4x, so minus 8x, and then plus 16. And I want to compare the trinomial that we get over here. That's called a perfect square trinomial with the original problem that we started with. And you'll notice that this last term, 16, is going to be 1/2 of this middle term, which is negative 4, squared. So in other words, if you took 1/2 of negative 8, you'd get negative 4. And then if you squared that, you'd get 16. And that's always going to be true in a perfect square trinomial. So in other words, if I took negative 8 and divided it by 2 and then squared that answer, that would give me 16, which is this last term. That always works that way in a perfect square trinomial. Let me give you another example. Let's say we had x plus 3 in parentheses squared. So when we FOIL that out, we'd get x plus 3 times another x plus 3, which would be x squared plus 3x plus another 3x. So if you put those together, it's plus 6x plus 9. And again, if you take this middle coefficient, the 6, and take half of that, that would give you 3. Then if you squared 3, you'd get the 9 here. So the middle number, 6, half of that, or divide that by 2, and then square that answer, would always give you this last term here, in this case 9. So expressions such as these are called perfect square trinomials, because if you have a perfect square trinomial, like x squared plus 6x plus 9, you can rewrite it as the square of a binomial. And the method I'm going to show you today uses that. So just to generalize what I just talked about, if you have a trinomial x squared plus bx plus c, that will be a perfect square trinomial only if that last number, the c, equals the middle coefficient b divided by 2 and then squared. Now what we're going to need to do is be able to find the number c that makes a trinomial a perfect square trinomial. So let's practice this. Let's say we had the trinomial x squared plus 20x plus c, and we wanted to figure out what number would we have to put in for the c to make this into a perfect square trinomial. So to find that, we would take the middle number, 20. Okay, I'll do this below. Always take the middle coefficient, the coefficient in front of the x, and divide it by 2, so take half of it, that would be 10. And then square that answer. So that would be 10 squared, which would be 100. And that tells us what that number c would need to be. So our answer would be x squared plus 20x plus 100. Now we need to try to factor this perfect square trinomial into the square of a binomial. So, in other words, these three terms make up a perfect square trinomial. We're sure of that because we added the 100 accordingly. And so we should be able to factor that into the square of some binomial. And it's always going to start with an x, and what comes after that is always going to be 1/2 of this middle number here. So it would be plus 10 in this case. So it would be x plus 10 in parentheses squared. Okay, let's practice this again on another problem. We have x squared minus 18x plus c. So first we have to find what number for c would make this into a perfect square trinomial. So to do that, we take this middle number, negative 18, and we'll divide it by 2. So negative 18 divided by 2, that would be negative 9. And then we're going to square that answer. So negative 9 squared would be a positive 81. So we'll be adding 81 in place of where the c is. So we'd have x squared minus 18x plus 81. So now we know this is a perfect square trinomial, so it has to factor into the square of some binomial that starts with x. And the number that comes after the x will always be 1/2 of this middle number, negative 9 in this case. Notice that's the same number we got up here, but before we squared it. So it's going to be minus 9. Now sometimes this can get a little bit messier because you'll end up getting into some fractions. So let's say we started out with x squared minus 5x plus c, and we're doing the same thing. We want to find what number for c would make this a perfect square trinomial. So we have to take our middle number, negative 5, and divide that by 2. Now negative 5 is odd, so we can't really divide that by 2 and get a whole number. That's what makes this a little messier. And then we'll have to square that. Now we're squaring a negative number, so it's always going to be positive when you do that. And in this case, you would just square the numerator and square the denominator separately. So 5 squared would be 25, and 2 squared would be 4. And that would be your c. So we'd have x squared minus 5x plus 25 over 4. Now we have to factor this into the square of some binomial. That's going to start out with an x, and what comes after the x, again, will always be 1/2 of this middle number, which is the same number that's inside parentheses up here before we squared it. So it's going to be minus 5 over 2. So you see, it is possible to end up with some fractions when you do this process. Okay, let's try one more of these examples. This one has a fraction in the original problem, but we're still going to do the same thing. So we're going to try to find the number c that would make this into a perfect square trinomial. So we're going to take this middle number, which is positive 1/7, and we're going to divide it by 2. So you'd have 1/7 divided by 2. Now when you divide by 2, it's the same as multiplying by 1/2. So I'm going to write it down that way this time. And then we have to square that answer. So that would be 1 over 14 squared. And then you would do the same thing we did before, square the top and square the bottom. So that would equal 1 over 196. And so that would be our c. So let's rewrite that now. It's x squared plus 1/7 x plus 1 over 96, 1 over 196. And then to factor that, we know that would have to factor into the square of a binomial starting with x, and what would come after the x is what's in parentheses up above here, 1 over 14, and it's positive, so it would be plus 1 over 14. So now that you understand how to complete the square and how to factor that into the square of a binomial, we can now learn how to apply this method towards solving a quadratic equation. Okay, so let's say we had the quadratic equation x squared minus 10x minus 2 equals 0. Now your first thing to check for would be to see if this left side of the equation could be factored, but it can't be. So, if you could factor that trinomial, you would do that, and then you set each factor equal to 0 separately, and you'd solve them to get your two solutions. And that's called the factoring method. So you'd usually want to check for that first. But since that trinomial can't be factored, we're going to switch over and use completing the square to do this problem. Now the first thing we're going to want to do to use completing the square is to get this constant term, negative 2, over to the other side of the equation. So we're going to add 2 to both sides of the equation. Because when we use completing the square, we want the constant term alone on the other side. So we have x squared minus 10x, and the 2's cancel, but I'm going to leave a blank space there. Okay? And then that equals 2. Now, in this blank space that I've left, I'll underline it right there, I want to complete the square. So I want to find what number would I need to add there to make that into a perfect square trinomial. So I will take half of this middle number, negative 10. So let's do this underneath. So negative 10 divided by 2, that'd be negative 5. And then we'll square that. So that's negative 5 quantity squared. That would be 25. So that tells me I'd have to add a 25 in order to turn that into a perfect square trinomial. Now, if I add 25 to the left side, I also have to add 25 to the right side, because this is an equation and I have to keep it in balance. So now that I've done that, I'm going to factor the left side into the square of the binomial. So we know that left side of the equation would factor into x, and remember what comes next is whatever's in parentheses here, so minus 5. So x minus 5 squared equals, and then on the right side we'll just add the two numbers together. 2 plus 25 equals 27. Now once we get it to this point, we finish it using the square method that we learned in a previous section. We learned that if we have something in parentheses, like we do here, and it's squared and equals a positive number, that the expression that's inside the parentheses, x minus 5, would equal the positive or negative square root of this number, 27. And so that's what we do next. You're really taking the square root on both sides of the equation, but you have to remember your plus and your minus here, okay, because 27 has two square roots. And then to get the x alone, you'd add 5 to both sides. And usually people like to write that in front of the plus or minus. So you'd end up with x equals 5 plus or minus the square root of 27. And those would be your solutions. Now it's important to realize there's really two solutions there. You have 5 minus the square root of 27 for one solution, and you have 5 plus the square root of 27 as your other. And if you wanted, you could put those into your calculator and you could get two decimals. But usually they're just left in their exact form like that, unless you're doing some kind of an application where the decimal would be better. So you can list them out separately like this, or you can just leave them together like we have right here with the plus or the minus in the answer. Okay, let's try this process on another example. This time we have the quadratic equation x squared plus 3x equals 12. Now in this case, the constant term 12 is already by itself on the right side, so that's good. But I'm going to rewrite this as x squared plus 3x and then leave a little blank here because I'm going to need to complete the square right there, equals 12. And then whatever I add to the left side, I'm also going to have to add over here to the right side. So to figure out what I need to add in, we're going to take this number, positive 3, and we're going to take half of it, so divide it by 2, and then square that. And again, since this is a fraction that doesn't divide evenly, just square the top and square the bottom. So 3 squared is 9 and 2 squared is 4. And that's what we'd add to both sides. So we'd say plus 9/4 here, and then plus 9/4 over here. Now this left side of the equation here is guaranteed to factor into the square of some binomial. And the reason we know that is because we've made it into a perfect square trinomial. It's going to start with an x, and then in this case it's going to be plus 3 over 2. So x plus 3 over 2 quantity squared. And on the right side, we just want to add these together. So get a common denominator and add them. So that comes out to be 57 over 4 when you do that. Okay, then we're going to take the square root on both sides. So on the left side, we get what's inside the parentheses, x plus 3 over 2 equals, and then the positive or negative square root of 57 over 4. And when you have a square root of a fraction like that, you can take the square root of the numerator and the square root of the denominator separately. So you could say plus or minus the square root of 57 over the square root of 4, which is just 2. And then we're going to subtract 3/2 from both sides to get the x alone. And we'll write that first on the left side. So we end up with x equals negative 3 over 2 plus or minus the square root of 57 over 2. And since these two fractions have the same denominator, and you're adding or subtracting them, you can combine them into one fraction. So you could say negative 3 plus or minus the square root of 57 all over 2. Now this next example is really important because there's something different about this one. In this quadratic equation, notice there's a number in front of the x squared. So the a is not equal to 1 here. It starts out with a 3x squared. And when you use completing the square, the method only works when you just have a regular x squared here with a coefficient of 1. So you can't have a different number in front of the x squared for this method to work. So we're going to have to divide everything by 3 to force that first coefficient to be a 1. So we'll just go through and divide everything by 3. And that sometimes is going to create fractions, but you have to do it anyway. And so what that will give us is x squared. 12 divided by 3 comes out to be 4x. And then you have minus 1/3. And then equals 0. And then from here, we'll just finish it the same way we did before. This constant term, negative 1/3, we've got to bring over to the other side. So we'll add 1/3 to both sides. So we end up with x squared plus 4x. Leave a little blank space right here so we can complete the square in just a minute. And that equals 1/3. And whatever we add to the left, we're going to have to add over here to balance the equation. So now, this is the step here that's where you're actually completing the square. You're going to take the middle number, 4, take half of it, so divide by 2, which is 2, and square that answer. So 2 squared equals 4. And that's what you're going to add to both sides. So plus 4 here and plus 4 here. And by doing that, this trinomial on the left side of the equation is guaranteed now to be a perfect square trinomial, which means it factors into the square of some binomial that starts with x, and it's going to be x plus 2 in this case. On the right side, we just get a common denominator and add those two numbers together. And that comes out to be 13 over 3. And so then we're going to take the square root on both sides. I'm going to continue up here at the top. So we have x plus 2 equals the positive and the negative. It's really important to remember the plus or the minus there. The square root of 13 over 3. And then we subtract 2 from both sides. So x equals negative 2 plus or minus the square root of 13 over 3. Now you could rewrite that as negative 2 plus or minus the square root of 13 over the square root of 3. And then if you rationalize the denominator by multiplying the top and the bottom by square root of 3, you would have x equals negative 2 plus or minus the square root of 39, because 13 times 3 is 39, over 3, because the square root of 3 times another square root of 3 is just 3. And that's a pretty good form for the answer to be in. I'm going to just leave it just like that. The only other thing you could do is to rewrite the 2 as 6 over 3, so you had a common denominator, and combine that all into one single fraction. So that could be another way the answer could look. Now, when you find the x-intercepts of a quadratic function, you're really going to have to solve a quadratic equation. Because let's think back, how do we find x-intercepts? Well, what we're supposed to do is substitute a 0 in for y. Okay, remember that's how we find intercepts. To find y-intercepts, we substitute 0 in for x. And to find x-intercepts, we substitute 0 in for y. You always plug 0 in for the opposite variable. So in this case, since we're trying to find the x-intercept, we'll plug a 0 in for y. Now y is really the same as f of x right here. So we'll substitute a 0 into the left side of the equation. And when we do that, we end up with a quadratic equation. And we have to solve that. So we're going to use completing the square to solve that. So let's move the 3 to the other side, because we know we need that over there. So we'll add 3 to both sides. So I'm going to switch the sides. So that really gives us 4x squared minus 6x equals 3. And remember, since we're going to be completing the square, we can't have this 4 in front of that x squared, because the process won't work then. So we have to divide everything by 4. And if that creates fractions, then we have to live with it. And it does here. So we have x squared minus, we have 6 over 4. We can at least reduce that down to 3 over 2 x. We'll leave a blank space right here, because we're going to have to complete the square in just a minute. And then we have 3/4. And whatever we add to the left, we're going to have to add to the right. So then we'll take half of this number. Now when you take half of a fraction, rather than dividing it by 2, you're better off taking the fraction and multiplying it by 1/2. Because dividing by 2 is the same as multiplying by 1/2. And then you're going to have to square that answer. So that would be negative 3/4 squared would be positive 9 over 16. So that's what we're going to have to add to both sides. So plus 9 over 16 here, and plus 9 over 16 over here. So that will give us x minus 3/4 quantity squared equals 21 over 16. If we take the square root on both sides, we'll end up with x minus 3/4 equals the positive or the negative square root of 21 over 16, which, since that's a fraction, we can take the square root of 21 and divide it by the square root of 16, which would just be 4. And then we'll add 3/4 to both sides, so we have 3/4 plus or minus the square root of 21 over 4. And since we've got two fractions with a common denominator and we're either adding or subtracting them, we can combine that into one fraction by saying 3 plus or minus the square root of 21 all over 4. Now, some solutions involve imaginary numbers, and that happens when we end up taking the square root of a negative number. When that happens, we're just going to want to write the answers in terms of I. So let's look at this example. We have x squared minus 8x plus 36 equals 0. So first we would just subtract 36 from both sides. So we have x squared minus 8x equals a negative 36. And then we want to complete the square, so we have to figure out what are we going to add. So we're going to take negative 8 and divide by 2. So let's see, negative 8 divided by 2 is negative 4, and then we're going to square that. So a negative 4 times another negative 4 would be positive 16. So we're going to add 16 to both sides. And now that we've done that, this left side we can factor into the square of x minus 4. And when we add the numbers on the right side, we end up with negative 20. And now we're ready to take the square root of both sides. And here's where you can see you're going to end up taking the square root of a negative number. And that's going to lead to an imaginary number. So you're going to have x minus 4 equals the positive and the negative square root of negative 20. Now we want to write the square root of negative 20 in terms of I. So to do that, think of the square root of negative 20 as being the square root of negative 1 times 4, because 4 is a perfect square, times 5. And when you split that up into 3 separate square roots, you end up with I, because the square root of negative 1 is I, and the square root of 4 is 2, and then square root of 5 I'm just going to leave as square root of 5. And since these are being multiplied together, that's really 2I times the square root of 5. So that's how we'd like to write the square root of negative 20, as 2I times the square root of 5. And that gives us x minus 4 equals plus or minus 2I times the square root of 5. And then we'll just add 4 to both sides of the equation. And so that would give us x equals 4 plus or minus 2I root 5. And those would be our answers. Now those answers are not real numbers. They're complex numbers because they involve I, or the square root of a negative number.